Hello, Andreas Hollmann here from Dresden, Germany. Today I want to continue the session which we started before, where we verify um, Amazon page using snapshot technology. And what we started to say in real snapshot, you never remove data. You always replace it. For example, if you have dynamic data like timestamps also, you never just verify it and remove it or ignore it. That's also not a good thing. You replace it by constant value, which represent your verification. Let me show you an example how we do this, which we started last time. Let's have a look. Now we verify this block on Amazon page, and this has some dynamic data like number of ratings or a rating itself. And what we did, we already started to verify this rating. And let me show you how it looks like. We created here in verify method a predicate with and, which verified this rating as a float, and it should be greater than 0. And all this was combined with AND operator, logical AND operator, and commented with ratings. So at the end we had this text here. Let me see. Yeah, here. It was like comment rating, then the description of the value, it was a float, and it was greater than 0. And then what I didn't like and what I promised to fix, it was this long JSON path of this you can see here this JSON path in IntelliJ. You could copy it also here because it is not maintainable. You don't really read it, and if something changes, it breaks. Of course, you can have use easy expression like it's here some stars like this here, but like this. So and somehow to identify it, but I don't like this because it's also not stable, not maintainable. Actually, to handle this, there's another options called tree predicates. Tree predicates. It's actually the same like value predicates, but uh, it's also predicates, and they extend also standard predicate from GDK, but it handles not string like value predicate, it handles a not. So, and it describes a node. And with that, you can find some nodes. That means all the tree will be searched for nodes which fulfill the condition defined by this predicate. For example, if I do something like has value, and has value, you see it expects here value predicate, and then I would say is float. So in that, what you see here, I don't like what you see here. I said, okay, search for all nodes which have a value, and value should be of type float. Actually, that's what you see here. Yeah, it's tree predicate and it's value predicate. If you see here in tree predicates, it's an overview. There are not so many, but they're really powerful. Okay, you have some logical operation, you have some has value, which again goes to value predicate, and here you can use all value predicates. Then you have some searching of in the tree like has ancestor or deceastor or parent, child, neighbor, whatever. Yeah? Is root, is leaf, but it's enough really to find anything you like. So let's do it. If I do this, actually, by that I already locate all nodes which have float value. In my case, in this snapshot, what remained, I have only one node, and it would be sufficient for me. Actually, this node which we replaced. And if I execute this, allocate this node and it will be replaced. Here you see it will be replaced. I mean by this string. If this node wouldn't be found, you will see here the floating number, which actually was the input for this value predicate. Okay. And so okay, let me continue. I want to verify this node. This is actually interesting node because it has a dynamic value and then it has a static part. And the static part, if you look, we have two nodes here, as I noticed. Yeah, this one and this one. You see, I have two nodes. That means if I can define a locator which defines both these nodes, then I would find them and I can replace them. First of all, let me show you how I can replace this one, copy qualified. Okay. First of all, I just verify this. Verify. And then, okay, value predicate. I will verify it by regex. And you see, here I prepared my regex, and then I will put my JSON path. Okay. Sorry, I copied completely. And here in this regex, you see a number is expected, then a dot, then I get a number, and then out of 5 stars string. This is actually what you see here. Number, a digit, then dot, and then digit, and then out of 5 stars. Yeah. And if I execute this one, you will see that this value will be replaced. Okay. Here you see by regex and out of 5 stars. But another value, this out of 5 stars, was not replaced because I used the path. Now the JSON path here. You see. Now let me use here locator instead of JSON path and describe this node somehow. And I will do it like tree predicate, then head value. Then I use value predicate again, value predicate, and this value predicate should ends with, and here a string is expected. So let me check what was the string there. It was out of 5 stars. So we have two nodes which are ends with that. And if I do this, I will find two nodes actually. Yeah. Okay, let me execute this. And so we have now match regex. Then we have this one. And that's with. And here you see both of them are replaced. First this one and this one out of 5 stars, you see. Here regex and here regex, which was used. But it's not really understandable regex. And the last what I show you today is how you can make it more readable. Again, I use for my value predicate, it's actually value predicate, custom name. It's not comment, it's really custom name predicate. And you see this one expects a string sorry, it expects the predicate name, string, and then the predicate itself. So let me give another name to this predicate. It's like rating out of 5 stars. It would be the name. And if I execute this, then you will see instead of this complex regex, because I didn't want to see this complex regex here, I want to see um, more description for this and for this. It would be replaced actually by the predicate name. And this is a constant value. So it's enough for today. Um, let me make next time more interesting verification process. For now, I just want you to know that the real snapshot technology works like you always replace the value, dynamic value, you never remove it or never ignore it. You always replace it. Because if you remove the value, for example, we did it sometimes with timestamps. We checked out the timestamps and we checked out timestamps and then we removed them because you can't be sure the timestamps were in original source. So you can't be sure you verify them. During verification, you need to check if the timestamps were occurred, and you can't. If you do this, you will fail immediately and you wouldn't see all failures in your snapshot. So there's only one possibility. You have to add this information to your snapshot. So during comparison of two snapshots, expected and actual snapshot, you immediately see all failures occurred in your test. So the right way is always replace dynamic values like timestamps by a constant value, which is describing these dynamic values, and all other ways are just not correct. So thank you very much. Um, if you like this content, please subscribe, and if you want to have this technology integrated in your project, please contact me. I'll be glad to discuss with you your requirements and the new idea. Maybe you have some great ideas and we can work together. I'm always happy um, to work with new people. So thank you very much. See you, Andreas Holman from ExpectedBits. Bye.